Number 14, the integral from 0 to infinity, x to the fourth plus 3x plus 1 over x to the fifth plus 2x squared plus 3 dx. This is very similar to number 13, but it's a little trickier. So let's go over the intuition first, and I'll explain why it's a little trickier. Okay. So as x approaches infinity, our function is going to behave very similarly to x to the fourth over x to the fifth. Once again, as x keeps getting bigger, the biggest degrees will dominate. Who cares about these lower degrees? So this simplifies to 1 over x. So our function is going to behave very similarly to 1 over x. And we know this integral diverges, so our integral is likely going to diverge as well. We're going to use this intuition to help us set up a comparison. Don't be like what the professor did and just say, oh, it behaves like 1 over x, and therefore it diverges. That's not a comparison. Okay. So I set it up in two different ways. We could compare it to 1 over x, but you have to be careful. First of all, we're unlike number 13, in which we're comparing with where our intuition was that it converges. Here, our intuition is that it diverges. So we want to compare it with something smaller to use the comparison test properly if this truly diverges. We have to compare it with something smaller because if something smaller than this guy over here diverges, then our thing will diverge for sure because it's bigger. But that's how we properly use the comparison test. And it is true that our function is greater than or equal to 1 over x, but you have to be careful with the interval that this inequality is true. It's true for x is greater than or equal to 2. Most people would probably just say, oh, this is true for x is greater than or equal to 0. But that's not true, actually. If your grader or your instructor is picky, then they will mark you off, maybe, and take off points, okay? So if you just blindly say, because we're taking this limit, probably, or most people are taking that limit probably if they're just putting x is greater than or equal to 0. First of all, it's not true because you can see we'll be divided by 0 here. So that inequality won't be true in itself. Even as we approach 0, this guy is actually going to be bigger because it'll be infinitely growing versus over here, it's still finite. So that's why that inequality would not be true and you could get docked. Okay? And you also can't just say, if you caught that and you just say x is greater than or equal to 1, it's not true either. Let's look at the graphs of these two guys. So this is our function, that rational function. And this is how 1 over x looks. You see that for sure, as x approaches 0, 1 over x keeps growing, so it's bigger. It's not smaller than our function. We can't use the comparison test properly there. And actually, even from 1 to whatever this point is, over here, 1 over x is bigger, the black curve. So that inequality wouldn't be true at all. So that's why in my solution, I wrote when x is greater or equal to 2, from this point onward, 1 over x is smaller. Then we can use the comparison test and say that since it's smaller and it diverges, our guy diverges as well. Okay, so you have to be careful with your setup. Let's go back to here now. Okay. So you would know that without a graph by just plugging in some values of x. So if you tried x is 1, you'll see that this guy is over here is bigger. Okay. Anyway, so hopefully you got that point, but we can still use this inequality if we have the right interval, okay? So we can rewrite our original guy as 0 to 2, 2 to infinity, 2 because of this over here. This first integral is proper, so it'll be finite. It's going to converge for sure. This one, we will compare with 1 over x. We know that 1 over x diverges from 2 to infinity. So by comparison test, since our guy is even bigger than 1 over x, for x is greater than or equal to 2, our guy is going to diverge, well, this guy is going to diverge as well. So this is finite, this diverges. So this guy over here, our guy that we want, diverges. Okay, so this is one way to compare. I have another way to compare that can avoid this mistake a little more easily. You still have to get the right interval, but this one, it's really not that obvious that it has to be x is greater than equal to x is greater than equal to 1. It doesn't even work, as we saw in the graph. However, in this one, it's a little clearer that x is greater than equal to 1 works. Okay, so I did it in a few steps, actually. So our original function is greater than equal to this guy over here. I just took out the 3x plus 1. Okay, so since the top has fewer terms, it's smaller, we're not adding as many things, this guy's going to be smaller. Okay, now if we restrict x is greater than equal to 1, we can easily convince ourselves that this middle guy is greater than or equal to x to the fourth over 100x to the fifth. Okay, this is much more easy to convince than up here. Okay, in my opinion, at least. I'm just showing you a different way of how I would set this up. Okay, so this we can simplify to 1 over 100x. Okay, so this is really similar to what we had up here, right? Just there's 100 on the bottom as well. But with that 100, it makes it much clearer that we can do x is greater than or equal to 1. And it's much easier to plug in values of x, actually. Okay? Well, it's about the same, I should say, because it's just 100 different. This factor of 100 different. But hopefully, just doing the steps here makes it clear that this will also work. And let me just graph it right away. It's this curve over here. X to the fourth over 100, x to the fifth. This one over here, you can see clearly that it's smaller from 1 all the way to infinity. Okay, let's go back to here now. So we can split up our original guy from 0 to 1, and then 1 to infinity. And then this one, we can justify that it diverges very similarly to what we did in comparison number 1. We just compare with this guy, which we know diverges. Okay. All right, so the point I want to make for this video one more time is you might get docked if you don't set up your inequalities and your interval of that inequality properly. So hopefully that is clear now. It really depends on how picky your instructor, your professor, or whoever is grading your exam, the grader, could be someone different, is. They might dock you points here and you might not get full credit if you don't set this up properly.